So in this video, we're going to look at using implicit differentiation to help find the equation of a tangent line to a circle. So it says we want to implicitly find the equation of the line that is tangent to the circle x squared plus y squared equals 9. This is a circle of radius 3. And we want to find the tangent line when x is equal to 2 in quadrant 4. Again, we need to know the quadrant because when x is equal to 2, we do have two possible outputs on the graph, so they're specifying quadrant 4. And we know that from work we've been doing so far this semester, we know that the equation of a tangent line is just going to be the slope-intercept form of a line, or alternatively, you could use the point-slope form of the line. But regardless, you need two pieces of information. You need to know the slope, and you need to know a point on the line so you can find the y-intercept. So if I start off with my x squared plus y squared equals 9, I do want to know the point on the graph that corresponds in quadrant 4 to x equaling 2. So to do that, I'm going to plug 2 in for x. So I get 2 squared plus y squared equals 9. 2 squared is going to be 4. And subtracting that 4 from both sides, I get y squared equals, it's going to be 9 minus 4 is 5. And then I'm going to take the square root of both sides. And you get y equals plus or minus the square root of 5. But because we're in quadrant 4, we need negative square root of 5. The positive square root of 5 would correspond to this point up here, where you input 2 and you get a positive square root of 5 as the output. So we don't need the positive square root. So in this case, because we know we're going to be working in quadrant 4, I wouldn't put plus or minus. I would just go straight to, hey, I need the minus 5. There's the point on the line that I need. Now we know that we need to know y prime when x is equal to 2. So we need to know the derivative at x equals 2 in quadrant 4. And I've drawn the tangent line in already. You can see that the tangent line slope is positive because the line's going uphill. So we know if we get a negative slope, we've made a mistake. So I'm going to take my x squared plus y squared equals 9. And because I need to know what y prime equals, I'm going to go ahead and take the derivative of both sides. So I'm going to take d dx of the left-hand side and d dx of the right-hand side. D dx of 9 is 0 because 9 is a constant. The derivative of a constant is 0. The derivative of x squared is just 2x plus the derivative d dx of y squared. So now I see that I have y implicitly defining a function of x, and y is inside the squaring function. So first we take the derivative using the general power rule. So we bring the 2 down into that coefficient position in front of the y, reduce the exponent by 1, so we get that 2 times y to the first power, which is just 2y. But by the chain rule, implicit differentiation means use the chain rule to get that derivative because we have one function inside of another. We need to multiply by y prime from the chain rule. 2y times y prime. Take the derivative of the outer function, which we did, times the derivative of the inner function. And because we need to know what y prime is, we need to solve this for y prime. So first subtract the 2x from both sides, which leaves 2y over y prime. And then divide both sides by twice y. And then when we do that, we get y prime is equal to the opposite of x over y. So negative 2 divided by 2 is negative 1. So there's what the derivative equals. So the nice thing about having done this implicitly is to find y prime, the derivative of y, we just need to know what x and y are when x is equal to 2. But they're just sitting there as an ordered pair. We already know what x is and y is. So to step up here and find y prime at x equals 2 in quadrant 4, we know that y prime equals the opposite of x over y, but x is just equal to 2, and y is just equal to the opposite of the square root of 5, which just equals, we have a negative divided by a negative, is positive 2 over the square root of 5. This is a positive number, which is good because the slope is positive. And you might want to consider rationalizing the denominator. We don't have to, but you might want to consider doing it. So if we do that, we get 2 square root of 5 over 5. So there's y prime when x equals 2 in quadrant 4, and the derivative is the slope of the line. So you replace the slope m with 2 root 5 over 5 plus b, and 2 root 5 over 5 times x plus b. And now to solve for b, we just plug in the point 2 comma negative root 5. So replace the function output with negative square root of 5 equals 2 square root of 5 over 5 times 2 plus b. So this is really going to be the opposite of the square root of 5, equaling 4 root 5 over 5 plus b. And then we can subtract this from both sides. So I'm going to step over into here where I have a little bit of room. I don't want to run this down into here very far. So let's bring over the work that we had. We have the opposite of root 5 equaling 4 square root of 5 over 5 plus b. We need to subtract this from both sides to isolate b. So we get negative square root of 5 minus 4 root 5 over 5. And to get a common denominator, we would multiply this by 5 over 5. So we get negative 5 square roots of 5 minus 4 square roots of 5 is minus 9 square roots of 5 all over 5. The common denominator equaling b. And so then you can finalize your tangent line function. The tangent line is equal to 2 root 5 over 5 is the slope times x plus b, but b is minus 9 square root of 5 over 5. So there's the equation of the tangent line when x equals 2 in quadrant 4.